We are now ready to run our simulation. In order to do this, we go to the Run dialog in Eclipse and choose Open Run Dialog. Alternatively, you can click on the green arrow in the menu bar. In the menu on the left, we find Infinity Simulation Engine here. And in order to run our simulation, we need a new configuration file. So we choose the New Launch Configuration option up here. And now we need to specify a number of things. We need to specify, for instance, which process model we want to simulate. So I'm going to browse, I'm going to choose my support case model. The simulation configuration automatically picks out the configuration that I have specified in my model file, the one from November 1st through December 31st. Of course, if I have multiple simulation configurations, I can pick one of the configurations that I've created here. I can specify the start of the simulation. So even though my simulation configuration is valid for 2 months, I can simulate a process that runs shorter than this configuration time. We have to specify the termination conditions for our simulation run. That means, when does the Infinity Process Platform simulation engine stop creating new cases and complete its work? The simplest option is the end of a time interval. So in this case, as it is on screen, the simulation would start on November 1st, 2009 and run through December 31st, 2010. So for a year and 2 months. We can adjust this, of course. We can say, I want to run this simulation only for a month. So let's say I want to run it from the beginning of November through the end of November. And apply. Other termination conditions are possible. They are the number of completed process instances. So I could run this simulation until I have answered 500 support requests. Or we run the simulation until we reach a certain application or participant queue length. This is useful if you know that there is a bottleneck in the process and you want to see until what time you can run this process when a participant has a particular number of work items that have queued up in front of this participant. So we could say, let's do this until the engineers have 10 work items in their queue. Finally, we can pick a transition in the control flow and specify how many times this transition should be traversed. So we could say we want the transition to notify customer or to deliver patch to be traversed at least 20 times, and then the process will complete. This is useful if you perform screening functions in a process, and let's say you reject certain cases. You can run the process until you have rejected 20 cases and see how many process instances overall you will have churned through in that period of time. Now we're going to keep things simple, and we're going to run this simulation for the month of November, just through the end of the time interval. Let's apply this. There are a couple of advanced features that we will get to later, but in brief, it is possible to run a simulation and to write the results of the simulation into the Infinity Process Platform audit trail, so we can use them using the same reporting mechanisms and dashboard mechanisms that we would use with a production workflow scenario. We can also derive our information in terms of availability and distribution statistics from an existing audit trail. But for now, we're going to keep things as they are. I'm going to click Run Now. I want to save my changes. And Infinity is bringing up a simulation tab on my right-hand side. The simulation is already completed. Because we don't actually invoke applications and we don't actually present users with work during a simulation run, it is very quick to run through hundreds, if not thousands, of simulation cases on the computer. So I can see my process statistics here. We have created 400 top-level instances. Let me maximize this. We have completed 111 cases, and we see the average duration is 250 hours, 17 minutes, and 26.1 seconds. The minimum duration is 6 hours, 34 minutes, and 50 seconds, and the maximum duration is 543 hours. For a support call, that clearly is too long, so it seems like our process has a lot of problems associated with it. Let's look at our activity statistics. Maybe that sheds more light on what happened. We see that we have performed 400 total instances of create case. Some of these had wait times associated with them. The execution duration on average was 10 minutes, and the minimum duration was 4 minutes, and the maximum duration was 15 minutes. So it seems as if, when we look at the wait time, already when customers are calling, they are not serviced right away. When we look at the init data step that comes before the create case step, 400 of these instances have been created. There was no wait time. They were completed immediately because this is an automated step and we can create as many parallel invocations of the support case factory service as we need. Once we move from create case to analyze case, we see that there are 141 instances of analyze case. That means that the 400 instances that arrived at create case have not been completed, and only parts of them have trickled down to analyze case. This step has a very long wait time, a very long maximum wait time, and you can see that the average execution duration is 2 hours and 47 minutes. Finally, we have delivered 40 patches to the customer, and we have told the customers 71 times that we would not solve their problems. The latter step, again, is an automated step, so it doesn't take a lot of time. So, in brief, what you can see here is that we have a simple help desk problem and we have bottlenecks in our problem that need solutions. We can take a look at our participant statistics, and the participant statistics tell us how many cases are waiting for an individual user. We can see that for every case that an engineer is working on, he has 149 cases waiting in the queue. Whereas the call center agents have 5 cases in their queue, and the Acme Corporation in general, which comes into play in the deliver patch activity, has a 0.4 case queue length. So this tells us we absolutely have a shortage of engineers, or we need to shorten the time it takes an engineer to solve the case. I'm going to restore the original screen again, and now we look at our process model and we look at the simulation parameters of our engineer. And when we look at the availability, we see that we have only 2 engineers. So how would this scenario change? How would the result change if I hired 2 more engineers? Let's move this up to 4 and click apply. I'm going to go back to my simulation. And what I can do now is I can click on my Save as Reference Statistic button here, and this will maintain the information from the previous simulation run. And now I can simply restart my simulation. I click on this button, and the simulation is done. Now the numbers in brackets that you can see here are the numbers from the previous simulation run. The numbers to the left of the bracket are the numbers from the current simulation run, where we doubled the number of engineers in our company. And as you can see, the queue length was significantly reduced, and we were able to complete 281 instances as opposed to 141 instances. So productivity essentially per engineer stayed the same, but overall productivity, because we hired more engineers, increased. If we look at the process statistic, the same number of process instances were created, but more than double the number of instances were completed. That is encouraging. We also see that the average duration for our process instances came down. So let's play with our process some more. Another thing that we could do is we could make the criteria for moving a case back to an engineer for reanalysis more stringent. So instead of 20% chance of reanalyzing the case, we move this down to 10%. Let's just assume that we are training our engineers better so they can solve the problems in the first try. And we will split the 10% that we saved between deliver, patch, and notify customer. So notify customer moves up to 50%. And deliver patch moves up to 40%. Transition probability. Let's see what impact this has on our process. We rerun the scenario and we keep the data from our first process run captured. Now we see that we were able to increase the number of top-level instances completed again by a number, not a large margin, but somewhat significant margin, and our average queue length, which in the previous run was around 90, went down to 67. So now the question is, what would we have to do in order to complete all of these cases? Well, one thing that we can look at is how many distractions our engineers have. So we already hired more engineers. When we look at their behavior, their efficiency rate is 40%. Maybe they have a lot of administrative duties that keeps them from actually doing the problem-solving work. So let's take some of the paperwork away from them and increase their efficiency rate to 60%. Let's see what the impact of this is. We apply, click OK, maximize the screen, and now we rerun the simulation again. And now we see that the average queue length went to 26 cases in the queue for an engineer, and 390 of the 400 cases that were presented to us could be completed. When we look at the process statistics, we see that the average duration now is 51 hours, the minimum duration is 1 hour, and the maximum duration is 146 hours. So roughly within a week, we can solve all the help desk calls that are thrown at us. And as you can imagine, now we can start experimenting more with hiring more people, expanding our service hours, training our call center agents maybe to solve some of the cases before they even get to our engineers. And all of this without having to deploy the process and tying up actual resources in the organization. Simulation is a very powerful tool to get concrete results of process reengineering efforts without having to go through the effort of implementing them.